G'day YouTube, Warbles on the lot here. Those of you familiar with the channel will be aware that I take climate science seriously, in particular global warming. And a lot of people claim that there's no proof that human activity causes global warming. And those people basically sort of annoy me. In particular, this channel has a troll. The troll, their channel name is Booty Q Coastal Real Estate. And they epitomise human denial, rationalisation and Dunning-Kruger effect in that their response to global warming was to move hundreds of kilometres from sea level to sea level. So, in the spirit of telling my troll where to go and enlightening everybody else in the viewership as to the absolute best source of the latest, greatest knowledge on the state of the art of what humanity actually does know about the climate, about what weather we're likely to experience in the future, how difficult it's going to be, how simultaneously the assault on our conception of normality is likely to shape up. It all comes to me recently from a Canadian climate systems scientist called Paul Beckwith. And yeah, today he showed up in my feed with a 41-minute video from the World Climate Association, which looks at all of it. And it's gloriously incontrovertible. I mean, if you've been wondering how to answer the carping of the denialists, this is it. This is it. Doesn't mean that we've got any serious, significant hope of changing any of it, but I like to know rather than to dwell in ignorance, because ignorance is not bliss. Anyway, let's go and we'll see what Paul Beckwith has to say. And yes, I take this shit seriously. Okay, forgive the state of the graphics. My production values are potato. But vital new report released by the World Meteorological Organization, not the World Climate, World Meteorological. State of the Global Climate 2024. Paul Beckwith channel. And 5,461 views in 21 hours, 414 likes, 124 comments. So not a huge channel, hasn't got a huge reach, but this stuff is gold. For the purposes of review and education.
More and more climate data and information from the US. So let's talk about this report. So first of all, you probably gathered, I'm Paul Beckwith, and I do a number of educational videos taking the latest in peer-reviewed science and distilling it in layperson's terms so the general public can understand it and figure out, along with me, join the dots on abrupt climate system mayhem, I call it. Okay, so let's go to the WMO website and the publication. So this was just released on, well, it says March 19th, 2025. I mean, it's March 18th right now, where I am in Ottawa, Eastern Standard Time. Europe is ahead, so the clock's already turned. It's March 19th. So it's hot off the presses, called State of the Global Climate 2024. Key messages: the key climate change indicators have reached record levels. Long-term warming is above 1.5 Celsius. Sea level rise and ocean warming are irreversible for hundreds of years. Record greenhouse gas concentration combined with the El Nino drove 2024 to record heat. Also 2023 was a previous record. And we need early warnings and climate services to protect communities and economies. So we reached, according to this report, a global mean near surface temperature of 1.55 plus or minus 0.13 degrees Celsius above the 1850 to 1900 average. 2024 was the warmest year in the 175-year observational record. We're getting massive economic and social upheavals from extreme weather and the long-term impacts of record ocean heat and sea level rise. Okay, and there is supplementary information on the major extreme weather events: floods, droughts, tropical cyclones, and wildfires around the world. Okay, so on this page, actually, you can select different components that you want. So the atmosphere, you can look at the basic data. I'll go over this data in detail. What's happening with glaciers, etc. You can click on all of these things, play around with it. It's presented in a very good fashion. All the links are going to be in my description. And you can go to the right bottom here and look at the state of the climate 2024, the key climate indicators. What are those? So you can just select here, and it brings you to these key climate indicators. And there's 10. Talk about greenhouse gases, temperature, ocean heat, sea level, Arctic sea ice, Antarctic sea ice, glacier mass loss, Greenland, Antarctic loss, precipitation, and short-term climate drivers. So they're all there, and you can expand all these. You can click on this and get more indicators. So I've done that. So this is the greenhouse gases. So CO2 continuing its rise upward. This is the yearly value. So it's not you can't see the sinusoidal fluctuation in it occurring each year, but you see the overall average, the background rise, and this curve is still bending upward. So CO2 is rising at faster and faster rates. This is the CO2 growth rate. This is the yearly change, and you can see there is quite a bit of variation. We went up to over, 3.5. Well, that wouldn't be 3.5. That would be about 3.1, 3.2 parts per million was the highest year. Anyway, you can see the trend. There's more. The growth rate is increasing. Therefore, this curve is bending upwards. So if you take the derivative of this curve, the slope, instantaneous slope, it basically is this curve here. This is for methane. You can do the same sort of thing. So the instantaneous, it looked like it flattened out here, went to zero basically for 2000, 2007 or so, and then it continued its sharp rise upward, having record year just a few years ago. So this curve is bending upwards as well, the methane. And this is the atmospheric nitrous oxide. And you can see that that's also bending up by taking the slope down here, the derivative, the growth rate. You can see that's also increasing at higher and higher growth rates. And these are both very powerful greenhouse gases. We can look in more detail at the global mean temperature here. So above 1.5 degrees Celsius. These are a whole bunch of different records. There was more scatter back here, but the curves are all very tight up here. They all agree, all these independent temperature measurements, there's 6 of them, all pretty much lock on and agree. This is global mean temperature overall, 1850 to 2024, and you can look at the land temperature, based the global land temperature, and that's difference from 1991 to 2020 average. That's the 0 point. You can see the rise here. Global sea surface temperature, and look at the spike just in the last couple of years. Massive spike upward, massive spike upward. James Hansen explains that clearly. You can see the temperature anomaly maps. the warmest parts. This is relative to a recent baseline, the most recent climatology 30-year average, 1991 to 2020. But you can still see, extremely large warming in 2024 relative to that even recent baseline up in this region here. This is Arctic temperature amplification in effect for sure. Also, the Antarctic temperature amplification. And you can see sort of a cooling over here. This is sort of the global warming hole. This is very serious, probably indicates that the AMOC is reducing in strength. Also interesting cooling here. You can correlate that to looking at what the ocean currents are doing in that region. This is the temperature anomalies. This is the uncertainty in it. Where the temperature uncertainty is, where the temperatures are the highest. There's the highest uncertainty. I think it's showing. And this is the annual temperature anomalies, the ranking, the ranking, and you can see, the areas areas that are hotter than before. Okay, we can go. So I'm arriving at these screens again by going to this first one on key climate indicators and clicking for more indicators in each of these 10 different cases. So we've got 10 key climate indicators, and I click for more indicators and it brings up a new screen, which I'm showing you. Okay, so that's how you arrive at these, but I'll put the separate links in my description so you can go directly to these things. So we just, we looked at the global mean temperature, we looked at the CO2 levels, and now ocean indicators. Of course, the oceans, 90% or more of the heating of the planet is going into heating the oceans. This is the ocean heat content to 2,000 meter depth from 3 different groups, and you can see, uncertainty tightening up. So there's more and more agreement, and it's still on a sharp rise. This is in zetajoules. The ocean pH is dropping as the oceans get more CO2, especially in the surface levels. You get carbonic acid in the seawater. That's acidic. It drops the pH of the ocean, which makes it difficult for shellfish to thrive, things like that. It has a huge implication if the ocean chemistry is changing. The atmosphere chemistry is changing. This is the area affected by marine heat waves, rising from about 50 to 70% in the 80s, coming up to 90% of the oceans having heat waves, marine heat waves. And this is showing cold spells in the oceans, and the number of those is dropping around the planet. There. Next, we can go to sea level, and you can see the sea level change is still, it's curving upwards. If you took the derivative and the slope, you would see that it's rising. You can see the sea ice extent. This is Arctic sea ice extent. March is when you've got most, maximum. Around March, around today, actually. Today is March 18th. We're coming up to the 21st, the equinox. Anyway, that's when we have sea ice maximum in March, the blue lines, and this is the sea ice extent in September, and you can see how the September value has dropped significantly. Are we going to get a blue ocean event soon? Well, if the AMOC holds up, I guess. Antarctic sea ice is doing crazy things. Up until 2010s or so, it was increasing at 1.5% per year. And then it dropped off a cliff. Now it's setting record lows, so the global sea ice extent is way, way down. This is the daily Arctic sea ice extent. You can see where we are, and if we extend this curve, we're way below at record low levels. You can go to the National Snow and Ice Data Center and look at that data on both Arctic and Antarctic. So this is where we are on the curve. We're below average on the curve too. So the global ice is really low. So it reaches a minimum because we're in the northern hemisphere, sea ice maximum, and southern hemisphere sea ice minimum, because the seasons are reversed, of course. So this is a curve for Antarctica. This is glaciers and ice sheets have changed since 1970. So if you take the cumulative mass balance, and this is the difference from 1970 to 1990 average, and it goes from 1950 to 2024, and you can see it's accelerating downwards as well. All these indicators are indicating climate change is accelerating, global warming is accelerating. This is the Greenland ice sheet mass balance, the change, and you can see it's also accelerating downwards. There's 4 different data sets that are plotted here, all in fairly good agreement. It gives you an idea of the uncertainty curve, which is the sort of the shadow, the envelope here. Antarctic ice sheet, 3 data sets. There is divergence here. This is interesting. Why this one has gone up, this one is kind of bottoming out. So it's interesting. Let's see if that continues in future years. Then there's precipitation. So this is annual precipitation. This is the very driest. It's the dark brown, areas that are in drought. Dry areas, the lighter brown. And then wet areas are blue, and very wet are dark blue. And you can see, there's a lot of areas over here, little splotches where there's excessive rainfall. Interesting, in Australia, this is in 2024, so fewer wildfires there. In these areas, very, very dry. And this is the precipitation. This is the anomaly, it's much, much drier than normal in these regions of South America, Africa. Okay, and then we have these short-term climate drivers or indices. So this is the ENSO index, the NINO 3.4, which is the temperature change in the middle chunk of the equatorial Pacific, which is used to monitor ENSO. And you can see, the El Niños, where it's, this is 2 degrees warmer than normal. Then you can see the La Niñas, which are cooler than normal. It's interesting, the trends seem to be working upward. So the El Niños are becoming more powerful. The La Niñas are becoming weaker. They're not bottoming out at such low temperatures. So the trends are upward for that too. This is the SOI, or Southern Oscillation Index. Lots of variability. These are parameters that climate scientists often talk about, and you can just look at the definitions of how these indexes come about. The PDO, Pacific Decadal Oscillation, at record lows. Indian Ocean Dipole, NAO, North Atlantic Oscillation. This is the IOD. You'll see these acronyms used. The Arctic Oscillation, or AO, kind of getting less and less variability. And then the Antarctic Oscillation, quite a bit of variability. So you can see all of these things, and they're all in the report, but they're nicely summarized as these different indicators. So again, key climate indicators, and if you just click for more indicators, you get all the stuff that I've just been showing you. Okay, so now, state of the global climate, 2024. I've shown you lots of the plots that are in this report already, but let's just have a quick look at the report. So just published, hot off the presses. It's by the World Meteorological Organization, which is based in Geneva, Switzerland. So, this data that is not from the US on climate is vitally important. It was before, and now it's priceless data, because we're losing a number of different data sources, as you know, if you watch any news or follow the political situation in the US. I don't need to elaborate on that. Okay, so this report is like gold. So it talks about the different key indicators in more detail, the patterns of temperature and precipitation, high impact events, and so on. It gives all the data sets and references and who contributed to the report, etc., etc. And they're actually asking for feedback on the report by answering a survey. Okay, so the summary again, the annually average global mean near surface temperature in 2024, 1.55 above the 1850 to 1900 average, warmest year in the 175-year observational record. It beat the previous record set in 2023. Okay, so this is a wake-up call. We're increasing the risk to our lives, economies, and the planet from climate change. Talks about the oceans warming, sea level rising, cryosphere melting at an alarming rate, glaciers retreating, Antarctic sea ice reaching second lowest extent ever, and the extreme weather events that continue to increase and have devastating consequences around the world. So the WMO, they're intensifying efforts to strengthen early warning systems to give people warning and provide climate services to help decision makers in society be more resilient to extreme weather and climate. They're making progress, but we need to go further and faster. Only half of all countries worldwide have adequate multi-hazard early warning systems. This must change. And this is good. Investment in national meteorological and hydrological services is more important than ever to meet the challenges and build safer, more resilient communities. So countries need to step up and invest and enlarge and increase the technology of their weather and hydrological services. And I can tell you one big country in North America, and it's not Canada, that's going the complete opposite direction to this, which is, it's going to expose Americans, all Americans, to incredible risks that aren't necessary. They're going to be extremely vulnerable without information if it continues to, if these systems aren't enhanced, let alone protected and kept in existence. Okay, so atmospheric carbon dioxide, in 2023, the atmospheric concentration of CO2 as well as those of methane and nitrous oxide reached the highest levels in 800,000 years, and they continue to increase in 2024. Okay, so this is just showing the plots that I've already showed you for CO2, and this is interesting, the effects. So when you get more CO2, of course, you get enhanced greenhouse effect, enhanced warming. You get more CO2 absorbed by the ocean, so ocean acidification goes up. This is the Sustainable Development Goals below, the number, like Climate Action 13, Life Below Water 14, etc. You also get effects on crop productivity, and you get changes to the nutrients in the soils, so you can get food insecurity dependent on the CO2. Air pollution affects health and well-being. Okay, so the now temperature, the global mean, and I talked about methane and nitrous oxide from the previous plots. Okay, so global mean near surface temperature, 1.55 above the 1850 to 1900 average, warmest year in 175-year observational record. 2023 was the previous warmest at 1.45. For each of the past, for global mean temperature, each of the past 10 years, 2015 to 2024, were individually the 10 warmest years on record. Okay, so there's this plot that they show, and I showed you a bunch of other ones. This is like 6 different independent groups looking at the data. There's some variability, but it's all converged from about this period, the 60s to the 80s and so on. It's like tightly constrained, and we're seeing a huge jump here in the last few years. And global mean surface temperature, of course, it affects everything. We get extreme weather events, floods, droughts, heat waves, wildfires. We get biodiversity changes and losses with species extinction in the water and on land. We get decline in agricultural and fishing yields, global health issues, food insecurity, conflicts, water scarcity, reduced livelihoods, displacement of people from extreme weather, damage, taking out their villages and cities and towns, built infrastructure degradation affects all these things, permafrost thawing, increased greenhouse gas release, additional greenhouse gas effects. So we get all of these different feedback, and all of this is, all the many sustainable goals are degraded. Ocean heat content in 2024, it reached the highest level in the 65-year observational record, exceeded 2024. For the past 8 years, each year sets a new record. The rate of ocean warming over the past 2 decades is more than twice that observed over previous time period, 1960 to 2005. We had a rate of warming, and we're double that since 2005. Okay, and this shows you, 3 groups, and the data is very close. There is some uncertainty. It's higher than that for land temperature. And the ocean heat content, we're getting more and more marine heat waves, higher greenhouse gas concentrations because the ocean sinks reduced, doesn't absorb as much CO2, algae blooms, eutrophication, lack of all the oxygen is used up, greater ocean stratification. When you get the surface water warming, that means you get deoxygenation down below, you don't get nutrients coming up, so you get loss of biodiversity, and biodiversity changes. You get coral bleaching, habitat degradation, natural heritage loss of beautiful places, reduced fishing yields, food insecurity, conflict, reduced livelihood, tourism losses. Okay, so all of these things are related to ocean heat content. Global mean sea level rise, it's increased from 2.1 millimeter per year between 1993 and 2002. It's 4.7 millimeters per year between 2015 and 2024. So that's, it's rising. It's rising at record rates. Set a new record in 2024. And the variability is related to the ENSO, which is also changing. And of course, with sea level rise, reinforced by extreme sea level rise events like wind-driven storm surges, etc., you get coastal erosion and flooding. You get built infrastructure, wharves and harbors, breakwaters degraded, soils degraded, slumps into the ocean of soils and, soil and water salinization close to the coast, biodiversity losses, leading to food insecurity, conflicts, displacement, reduced livelihood. So these things are all connected. The ocean pH, the ocean's getting more acidic. Okay, the ocean pH is changing at the rate of pH is going down, so it's getting more acidic. And this decline of pH, of course, is called ocean acidification. And it looks like the curve is bending down. It's not a line, it's increasing, or the pH is dropping rapidly, the curve is bending downwards, so it's nonlinear. And ocean acidification, of course, it degrades coral formation, which hurts tourism, and natural heritage is destroyed. Think of the Great Barrier Reef around Australia. You can't get marine shells and skeletons to form, to calcify, so you get marine food web changes, you get fishing yields down, food insecurity, reduced livelihoods, and conflicts, all of these things happening from ocean acidification. Glacier mass balance, exceptional negative mass balances in Norway, Sweden, Svalbard, tropical Andes. We've had the most negative 3-year glacier mass balance loss on record. 7 of the 10 most negative have occurred since 1950 have occurred since 2016. Okay, so glacier mass balance, it's also bending down sharply. It's nonlinear, it's accelerating. And you can see what it affects. The glacier mass balance, it weakens the ocean thermohaline circulation. Get more and more melt, more and more fresh water in the surface layers. That lowers the vertical mixing of the ocean, weakens the thermohaline circulation. You get less The ocean sink for carbon is reduced with less vertical mixing. You get changing global weather patterns. You get biodiversity changes and species extinction. You get melting of freshwater resources, water scarcity and pollution. You get flooding, reduced agriculture yields. You can get landslides, mudslides, avalanches on coastlines where the glaciers melt back, built infrastructure degradation downstream, loss of natural heritage, the glaciers, and tourism losses. So all of those factors. The sea ice extent, this is the Arctic, this is the Antarctic. I've talked about those previously. I like the sea ice extent. With less and less sea ice, you get more and more exposed ocean's darker surface than reflective ice and snow on the ice. So you get a reduction of albedo. You get enhanced radiative forcing, a vicious feedback causing more and more warming as you get less and less ice. You get ecosystem and habitat degradation for creatures that live or hunt on the ice, hunting grounds and fishing stocks for people, reduced livelihoods, food insecurity for northern peoples, and biodiversity changes and losses, species extinction. You get, with sea ice gone, the commercial ships can go in and fish and exploit the resources under where the ice used to be. You can get overfishing and hunting, new transportation routes, water pollution, and conflict over these new transportation routes. Okay, the ENSO, this is the El Nino effect. It's a global phenomena. When you have an El Nino, you tend to get drier regions and wetter regions, and it affects things on a global basis. And so temperature and precipitation patterns, I talked about those. I showed you those plots previously, the key indicators. Now, high impact events. There's a supplement on the extremes, and I'll talk about that. This just gives some of the highlights of extreme weather events in 2024 led to the highest number of new displacements of people recorded in a year since 2008. Destruction of homes, critical infrastructure, forests, farmland, and biodiversity. These extreme weather events undermine resilience. They pose huge risks to people on the move and those already living in displacement. And these shocks are compounded. You get more conflicts, drought, high domestic food prices, worsening food crises in 18 countries globally by mid-2024. So high food inflation, 8 countries had at least 1 million more people facing acute food insecurity in 2024 than during the 2023 annual maximum. Reduced global cereal harvest, widespread drought, tropical cyclones, some really major ones. In the U.S., there was Hurricane Helene in September and Hurricane Milton in October. Major events, too many deaths, many, huge dollar value for these storms. And there were storms in other parts of the world, okay, but they're covered more in this report. So I'll go and talk about some of these details when I show you the report. Monitoring global temperature, best estimates of current global warming. They use various methods. If you take an average of the previous 10 years and the next 10 years, well, yeah, you're under 1.5. I mean, you can play with the numbers however you want. But we're 1.5 and we're going to stay above 1.5. They talk actually a little bit about the aerosols, the International Maritime Organization, rules on shipping fuel. Finally, they're starting to talk about that. The Hunga volcano eruption, aerosol reductions in East Asia, patterns of dust over the Atlantic and Antarctica from Sahara. So they show all of these different effects and the residual to try to explain why it was so warm in 2023 and 2024. So that's what they're doing, invoking all of these different factors. So this is interesting to look at this analysis in light of what Hansen has said. And then the rest of the report is all the data sets and stuff. Okay, so the link is in my description of this video. I just want to show you quickly this report. Significant weather and climate events, and it's it's a supplementary report, and it looks geographically at different regions and talks about what's happening. Looks at overall global tropical cyclones. Okay, so 2024, we had a near average total number of tropical cyclones globally. There were, in contrast to 2023, there were relatively few long-lived cyclones. So the accumulated cyclone energy ACE index combines intensity and duration. That was lower in 2024 than 2023. There were 86 tropical cyclones in 2024. That's numbers close to average in both the northern and southern hemisphere. North Atlantic had an above average season of 18, below average season in the Northeast Pacific of 13. It had the latest, in the Northeast Pacific, had the latest season start. And so they talked about the cyclones around the world, and the ACE index was below average because there weren't really long storms. In the North Atlantic, it was the first season since 1919 with multiple Category 5 hurricanes. And they talked about notable cyclones that occurred. Okay, so basically, Africa, they divided up and looked at the different regions. So Africa, exceptionally wet monsoon, long-lived and extensive flooding in 2024, and also in the Sahel. Rainfall was more than 50% above average over much of the region. Significant flooding in almost every country in the region. Heavy rains extended into the Northwest Sahara, significant flooding in the desert in various places, 639,000 houses damaged or destroyed, over 1 million people displaced across the West and Central Africa region. Who even knows about these sort of things happening? We just don't. There's so many things happening, we just don't get them. This is 29th of April, 2024, and this is, May. And you can see all of the greening of this whole region because of all of the rainfall, right? And there's huge vegetation growth after all that rainfall. So they go and talk about all of the other extreme weather events in Africa, the heavy rains, lake levels, etc. But this doesn't really make it out to Western news sources. So I'm glad it's all covered here in this report. Asia, extreme heat wave in Saudi Arabia, the Hajj pilgrimage reached 50 Celsius, 43 on every day from the 1st to 22nd of June, 1301 deaths during the pilgrimage. And they talked about the extreme heat buildup and cyclones, very hot summers, and so on. Okay, so you can see, you can look at each region, flooding, heavy rainfall. I mean, there's extreme weather events that are accelerating around the planet. This is pretty clear. We've destabilized the weather systems because we've destabilized the climate system. There you go. Typhoon Yagi in Asia, record-breaking landfalls in China and Vietnam, more than 700 lives lost. Who even knows about that storm? And Persian Gulf, heavy rainfall. South America, some of the most destructive fires in Chile, late January, February, dry conditions typical of summer, combined with low humidity, high temperatures, strong winds, produced these fires. Santiago, 5 days above 35 Celsius. And fires moving rapidly, killing people, destroying homes. Okay, so this is fire south of Vina del Mar, Chile, the most deaths known from a wildfire in South America in this region. This is Santiago over here. Okay, so there's more info. This is flooding in Brazil, causing several $1 billion of losses. Look at this picture here. It looks like a river is flooded. All the muddy water's gone into this town, Porto Alegre, Brazil. Right? I haven't even heard of this stuff. North America, Central America, and the Caribbean. They talk about the Rainfall totals from Hurricane Helene. Landfall is a Category 4, 26th of September, tracked northwards over the interior, southeast of the U.S. Intense flooding, landslides, up in the Appalachians, almost a meter of rain in some places. Asheville, was badly damaged with, big loss of life from Helene, the greatest loss of life in the mainland United States hurricane since Katrina in 2005. Economic losses at US $78.7 billion. And it was an inland flooding event in the US. The water was dumped from Helene, and then 2 weeks later, Hurricane Milton hit Florida, Category 5, 290-kilometer sustained winds, 897 hexapascal, very powerful storm, and deaths and storm surge, and $34.3 billion. Okay, so big, huge costs. Like I say, you can ignore climate change, but climate change isn't going to ignore you. Make sure you get the T-shirt. Mexico, most active wildfire season on record. Right, you can go through and look at this report and see, it's very important, I think, that everybody read it. Look at this. Even in Canada, a hailstorm with hail 7 to 8 centimeters in diameter hit Calgary on 5th of August. Widespread damage to cars. Insured losses $1.8 billion, which is the most for a hailstorm in Canada. There you go. I vaguely remember that storm, hearing about it. Southwest Pacific, between 24th of October and 17th of November, 5 tropical cyclones made landfall in the Philippines, all crossing the island of Luzon. Look at all this flooding and stuff. So the weather weirding, wilding, whiplashing is whipping our butts around the planet, basically. New Zealand, Philippines, Europe, flash flooding. Of course, the Valencia, Spain was, a huge event. Estimated losses from flooding in the Valencia region were $17.5 billion. Look at the flooded areas here in the town, the river, all of the mud coming out into the sea. Right, really catastrophic flooding, and they talk about temperatures in Svalbard and setting records and so on. Agricultural losses from drought in Sicily, 3 billion euros. Right, and there's reference to all of it. It's very well referenced. So if you want one go-to source for all of the extreme weather and climate events in 2024, this is a report, the WMO report. So it's really, really vital information. So again, thank you for listening. So again, just in summary, there's 2 new reports out: State of the Global Climate 2024 by WMO, the European organization, World Meteorological Organization, and an associated report, which is all about the weather and climate extreme events around the planet in 2024. Okay, well, thank you for listening. Please consider going to my website, paulbeckwith.net, and donating at PayPal to support my research and videos. Thanks again, and bye for now.
Okay, there you go. Now you know, and my excuse is, once he started talking, I was too polite to interrupt because there was nothing I could say that was going to be better than that. Like he said, it's the best overview of all that stuff that I have encountered thus far. And in the face of this, Kremlin's Quisling has been manipulated to be inaugurated for a second time, despite having run an insurrection. I think it's better to be informed than living in ignorance. But you be your own judge. And I don't know about you, but in my view, as convenient as fossil fuels prove to be in the short term, even though it turns out you can improve them if you add a solar power system onto the roof, the long-term effects of the endless pursuit of such convenience turns out to be absolutely, officially catastrophic. In real life, taxpayers' dollars acknowledging the fact that your fire risk any day of the week, any season of the year here in Oz, because of anthropogenic global warming, can be anywhere from moderate to catastrophic unless you've just had a really big high rainfall event, in which case you won't have a fire risk, and that's the situation here and now today. So therefore, thus, and because, I reckon it doesn't matter quite what it costs to be able to use the passing sunlight (800 watt), 93% efficient, 60 volt, 12 amp. To be able to use the sun overhead today to recharge after yesterday's trip to town for 2 loaves of bread, basically, without having to burn any refined petroleum transport fuel which has come into Australia from Arabia, Singapore, Venezuela. I think it's worth doing. I won't pretend that it's cheap to set up, and I won't pretend that it's going to be feasible to run a motor car the size and weight of something like that on solar panels and gel cells, unless you're prepared to bring about $250,000 to the table for a 50 kilowatt hour electric vehicle, because that's $10,000 to recharge a 2.3 kilowatt hour battery. You have to cut your coat according to your cloth. Guess who could not afford a solar electric plug-in motor car equivalent? Fact is, most of the time my life runs between no fire risk and a moderate fire risk, and we get into the high fire risk from time to time, and it's a bit rare that we get to the extreme. And yeah, I've lived through the catastrophic fire risk times, and it's bloody scary. The slower we can go from living around here all the time to living around here, say, half of the time, the better I think it's going to be. So I would rather spend 10 or 15 years worth of fuel money to feed one of them and put it into this stuff and go around at half the speed. It just seems to me to be a more responsible way of living on planet Earth at this time. I don't see how I would have any excuse at all whatsoever to have spent the money from the bike, from the solar gear to feed the bike, on updating to say a 10 or 12-year-old Subaru instead of the 25-year-old one that I drive, and I have been driving for about 10 years. I figure if I keep that one in repair and use as little as possible and replace it with a solar electric motorbike, then yeah, I'm not living as clean as people did who were living here 300 years ago, but I'm trying because I acknowledge that this is the reality. And yeah, if you want to watch a much clearer high definition version of what I just presented to you from phone to phone, pirate copy for review, here's my review. Paul Beckwith is doing the best popular awareness raising videos about anthropogenic global warming of anybody who's on YouTube or anybody that I've heard of in any media. Go and subscribe to his channel, get onto his website, become a Patreon of him if you can afford it. I can't, you know. I'm flat out buying the bread to feed the kangaroos with. But there you go. Now you know that's my highest, most respected source of information on global warming at the moment, superseding ABC Radio National Science Report. Yeah, and I stopped buying New Scientist magazine when I got the chemotherapy for the evil twin that was trying to strangle me. Anyway, Warbles on a lot to YouTube. Go and check on Paul Beckwith's channel. Ciao. Kangaroos like clearing. Bonus extra footage.